today's topic is indeed the Techila system, which is now freely available for academic use for CSS customers. And we have a guest appearance, Marko Koskinen from Techila Technologies, and he will introduce to you the Techila system and how to use it with the R language and with the CSS resources specifically. If you have any questions during the presentation, you can, for example, type them in the chat window or use the button in Adobe Connect to put your hand up, and we'll get to them at a suitable moment. But now, Marko, please go ahead.
Thank you, Seija. So, as Seija mentioned, today we will be discussing how you can use the Techila system from R, and more specifically how you can use the Techila system in CSC's title cluster. And here you can see the agenda for today's webinar. I will be starting with a short demo to show you how you can push computation from a local R session to a Techila environment to accelerate the computations. And after that, I will give you a very brief introduction to the Techila high-performance computing middleware system. And after that, I will demonstrate how you can configure the Techila software development kit so that you can connect to the Techila environment running in CSC's title cluster. And after that, we have time for questions and answers, where I will try to answer any questions you have. But to start, as promised, I will show you a demo, just to give you an idea on what I mean when I say that we can accelerate computations. So this is an RStudio session running on this computer, so it's a local session. And on this computer, I have also installed a piece of software called the Techila software development kit. And this Techila software development kit contains all the necessary bits and pieces you need in order to connect your computer to the Techila environment. And Techila SDK contains an R package, and I have also installed that on this computer. So now I'm able to load the Techila package using the standard library Techila command. And this will give me access to the Techila helper functions that are in this package. And one of those helper functions is this cloud core function, which can be used to replace computationally intensive for loop structures so that the iterations are executed in the Techila environment instead of on your local computer. And in this case, we have two nested cloud core loops, as you see here. And during each iteration, these two lines of code will be executed. And I will not go into the technical details with this demo. I will just give you an idea on what it looks like when you are pushing computational workload from one computer to the Techila environment. So now I source the file, and now I have access to this run_agent cloudcore function, which will push the computational workload to the demo environment I'm using. And here so in the code, there was this cloudcore helper functions which are included in the Techila SDK, and these are used to push the computational workload into the Techila environment. And now I'm just going to redo what I just did, and let's hope that the sharing keeps chugging along.
Yep, looks much better now.
Good. So now I ran the code, and we see this project status window. And in the demo environment I'm using, I have 40 CPU cores available. And the number 40 in the yellow arrow means that there are 40 Techila jobs being processed at the current time. And if I would have more jobs running, more CPU cores running, I would be able to compute more jobs at the same time. But in this case, we are working with 40 CPU cores, so we get have the value 40 here at the yellow arrow. And the green area means jobs that are completed. And whenever a job is completed in this example, it will be streamed back to this computer, and the result will be visualized in the graph you see here. And as we get more and more complete data points from the Techila environment, the graph will be updated to match the result data. And now we're just waiting for the last jobs to complete. And now the project has been completed, and I got the results straight back into this local R session. So I didn't need to work with any output files, or I didn't need to log in to any remote node. I was able to push the computations to the Techila environment directly from this local R session, and I got the results straight back into the R workspace. And this is the result data. So this is a 10 by 10 array. In this case, we had a nested Cloudflare loop structure, and each loop consisted of 10 points. So we actually calculated the values of a 10 by 10 matrix, which was visualized here. And this is the actual numerical result data that we got. And then we also get some project statistics about the project that we just computed. And probably the most important or interesting bits here are these two lines here. So the total CPU time used in this case was 34 minutes. And this means that the Techila system used 34 minutes of CPU time to process the computational workload in this project. And the workload time used tells us how many minutes and seconds it actually took to complete it. So in this case, we were able to do 34 minutes worth of computation in just over 1 minute. So that was the demo I promised. So that was me pushing computational workload to a Techila environment from a local R session where I had the Techila software kit installed. Next, I'd like to give you a short introduction to the Techila system. So I have a couple of PowerPoint slides. And after the PowerPoint slides, I will show how you can configure the Tequila SDK. So there are a lot of parameters in the R script you see here, but I will discuss those parameters in more detail later during this webinar. So to answer the question how Techila actually speeds up the computations, hopefully the demo I did answer that question at least somewhat. But just to reiterate, Techila speeds up the computation by dividing the computational problem into smaller parts, which we are then able to solve simultaneously on a large number of CPU cores. So we are not just using fast computers, we are using lots of CPU cores to process small parts of the problem at the same time. And then I have some guidelines, so to say, about what types of applications are typically well suited for Techila and maybe in distributed computing in general also. And one of the most commonly encountered situations or cases we have are these Monte Carlo type simulations where we rely on random number sampling to solve a problem. And these are typically very CPU intensive and don't rely on generating lots of output data or reading input data, meaning that they are very well suited for a distributed computing system such as Techila. And another example use case is, for example, if you have 100 different audio files and you want to analyze each of those audio files by using your R script. This can also be very easily done by using Techila, so we can specify the R script we want to use to analyze the input data files. Then we can send that script to the Techila environment along with any input files we need in the analysis. And then, of course, if you have any case where you are doing parameter sweep type computations, Techila is very well suited for those as well. But if you have a problem where you have strict recursive dependencies, such as when computing MC-MC chains, then Techila is not suited because of those dependencies. But then again, if you're working with MC-MC chains, even though you cannot divide that single MC-MC chain into small independent parts, it's of course possible to run several of these MCMC chains parallel in Techila by, for example, using different seeds, which can be beneficial in some cases. And then I have an illustration of our Techila environment and a small animation on what actually happens when you push computational workload into a Techila environment. So in this graph, we have the three components that make up the Techila environment. So we have the end user using R on their own computer, and they also have the Techila SDK. And then we have the Techila server and the Techila workers. And the Techila workers are the computers that provide the actual computational power that will be used to solve the computational problems. And the Techila server will act as the communication endpoint between the Techila environment and the end user. So whenever an end user wants to push computational workload to the Techila environment, it's sent via the Techila server, which then distributes it to the Techila workers. So now I'm going to show you a small animation on what happens when a user creates a computational project. So it starts by establishing a connection by using the Techila SDK. This connection is secured by using SSL, and it is also authenticated by your own personal user credentials. And after this network connection has been established, the end user has access to all of the computational capacity in the Techila environment. And similarly as between the Techila server and the end user, these network connections are also secured using SSL. So now, when the end user wants to push computational workload to the Techila environment, it's done by sending it to the Techila server. And the Techila server will then distribute the computational data packages to the Techila workers. So these computational data packages include any R scripts that contain functions you want to execute, any possible input data files you want to send to the computational nodes, pretty much anything you need during the computations. It's sent from the Techila server to the Techila workers automatically. And after the Techila workers have received all of the necessary components required to process the workload, they start processing it. And as a result, they will generate an output file, which will automatically be sent back to the Techila server and then back to your computer. And this all happens automatically. So when I ran the demo project earlier, all of the activities I just described happened automatically under the hood, so to say. So data was sent from my computer to the Techila server. The Techila server distributed the necessary files to the Techila workers, which then processed the workload and sent the results back to my computer. So that is a very quick and dirty introduction to the Techila system. And then I have some title-specific information about the Techila system. So currently, there are 36 title nodes that can be used for processing Techila jobs. And each of these nodes can process 12 jobs at the same time, meaning that the system is capable of processing 360 jobs in total. And currently there is no code limit per user, so if you are the only user using the Techila system, you will get access to all of the cores. If there are multiple users using the system at the same time, the Techila system will share the computational capacity so that each user will get at least some CPU power. And then to answer the question, how can you get Techila access? CSC has written a nice set of instructions in the website you see here. So that page contains a getting started section that lists the steps that you need to do. And this page also contains a link that you can use to download the Techila software development kit, which is needed to connect to the Techila environment. And I will show this page in the link in just a couple of minutes when I show you how you can configure the Techila SDK for the Techila environment in CSC. And the Techila SDK contains lots of useful material for getting started with using Techila. So it contains examples for several popular programming languages, including MATLAB, Python, and R, and there are quite thorough documents for these programming languages. So pretty much all of the information I'm talking and giving to you during this webinar can also be found in the documentation. And in the Techila SDK, there is the Techila R package. And the Techila R package contains a couple of helper functions. And the first one I'd like to briefly discuss was the Cloud for helper function I used during the demo. So this Cloud for function can be used to replace computationally intensive for loop structures so that the iterations are executed in the Techila environment instead of on your own computer. And I have a couple of examples here that illustrate the local version by using a standard for structure and the Cloud for equivalent version where the operations will be executed in a Techila environment. So in this case, we have a local loop that has 10 iterations where we just multiply the value of the iteration counter by itself and store the result in the array. And the Techila counterpart is quite similar. I'll just go through what each of these lines actually does. So we start by loading the Techila library, which gives us access to the Cloud for helper function. So after this line, we're ready to use the Cloud for helper function. And when we want to use the Cloud for function, we want to define which variable will store the results. So in this case, we store the results returned by Cloud for into the result variable. Then we define that we want to iterate over from 1 to 10 for the value I. And then we have this .r version equals n. This is specific to the CSC Techila environment, and this is needed in order to use the R installation available on the title nodes themselves. So this is something that is not included in the example material by default, but you just need to make sure that you have this line here in every example that you try to run. Otherwise, you will run into somewhat cryptic error messages, and I'll show you what the error message looks like when I do some demos in a couple of minutes. And so that's the first Cloud for syntax. So we define the range over which we want to evaluate the value I, and then we close it off. And then we have this %t notation. So this %t notation marks the start for the code block that we want to execute in the Techila environment. And in this case, we have this multiplication operation I times I, which is the same operation that's executed in the local version during each iteration. This is very trivial, and in a real world use case, you wouldn't want to execute this in a Techila environment because it would be slower due to overheads related to distributed computing. But this is just to illustrate the simplest possible case and conversion, how you can convert a local for loop structure to a cloud for loop structure. You can execute pretty much any function you want in this cloud for loop. So if you have functions that you have written yourself, you can use those there, no problem. And then the other example we have on this slide, we have a nested local for loop structure where we store the results in a matrix. And the Techila counterpart looks quite similar. So we again start by loading Techila library, and then we want to state that we want to store the results into the result variable. And then we have the two nested cloud for loops. And the outermost cloud for loop is marked with this %to notation. And then we have the innermost cloud for loop, which is marked with this %t notation. So this %t notation tells the Techila package that we have more cloud for statements coming, and these are used to mark any outer cloud for loop structures. So if you would have an additional cloud for loop structure here, you would define cloud for and then %to for that as well. So only use %t for the innermost cloud port loop structure. And again, we have this R version equals n to make it run in time. So this is the cloud port helper function. And the cloud port helper function automatically detects which workspace variables and functions need to be transferred to the Techila environment. So if you are using some custom functions in this that you have written yourself and are dependent somewhere in the R script, the function dependency is detected automatically and transferred to the Techila worker. If you're working with some packages, those can be transferred by using a slightly different syntax. But that is not that difficult. So even if the functions you want to use are not included in the standard R distribution, you can use those as well. You just need to specify one additional parameter to make the Techila system transfer the package from your computer to the Techila environment. And then another helper function I'd like to mention is called Peach. And Peach is the fruit, but it's also an acronym for parallel each. And this parallel each or Peach is a simple interface for executing computationally intensive functions on workers and typically with different input arguments. So essentially for parameter sweep type operations. And at minimum, you want to define some parameters for the Peach function that define what you want to execute. So the name of the function, you want to define input arguments for the executable function. And then you can also define, for example, a list of data files that you want to transfer to the Techila environment from your computer. And then you want to also define the number of jobs in the project. And I'll actually go through the syntax you see here just to explain a bit on what each of these lines do. So we again start by loading the Techila library, and then we set some values for local variables. Then we have the Peach function call, and we define that we want to store the result of the Peach function to the result variable. And then we have the actual Peach function syntax. So from here all the way to here. And the function parameter defines the name of the function that will be executed in the job. So in this case, we have the worker function here in quotes, meaning that each job will execute a function called worker function. And the params notation is used to define input arguments for the executable function. So with this syntax, the Techila system will give two input arguments to the worker function each time it is executed in jobs. And the value of this var1 is set to 5 here, and it will be the same for each job in the project. And then we have a comma, and we have the second input parameter, which is this param notation. And this is a special notation in Techila and is used to implement the parameter sweep type computations. So this will be replaced with a different value for each job. In this example, the value of this will be 1 in job 1, 2 in job 2, and so forth. And then we have the files parameter, which is used to define a list of files that will be sourced at the start of the job. So in this case, we have the file underscore list.r here, meaning that a file with this name will be sourced at the start of the job. So this file needs to be on your computer in the current working directory, from where it will be sent to the Techila environment and sourced at the start of the job. And this function would in this case also contain the definition for this worker function so that it can be called in the job. And then we have the Peach vector parameter. This has two roles in the computation. The length of the Peach vector defines the number of jobs in the project. And in this case, we have the value 10 here, meaning that the length of the vector will be 10, which in turn means that the number of jobs in the project will also be 10. And then the elements of the Peach vector will also be used to replace the values of this param notation here. So in this case, we are working with integers, meaning that it will be values 1, 2, 3, 4, and 5 for jobs 1, 2, 3, 4, and 5, and so forth. But you could also have different types of data structures here. So you are not just limited to integers. And then we have the parameter to define the R version. So it's set to n, which is again needed when running jobs on Titan nodes. And then we have this SDK root parameter, which is used to define the location of the Techila folder on your computer. So that was the PowerPoint's part, pretty much. And now I will show some demos on how you can get started with getting access to the Techila environment in CSC and how you can do the actual configuration so that we can run some simple test projects there. And the first thing you want to do when you need to get access is to check out this site that I mentioned earlier. Just minimize that. So this is the Techila information page on the CSC website, and here we see this getting started section. So it has 4 different steps you need to do. The first thing is to register as a CSC customer, and after that you can send an email to servicedesk@csc.fi and ask for Techila credentials. And when they reply, they will include an attachment in the email, which will be a file with a JKS suffix. So that is a Java key store file, which is password protected, and that contains your personal user credentials that are needed in order to use the Techila environment in CSC. And after that, you can click this link here to download the Techila SDK to your computer. And now I have done some of those steps already. So I have sent them, well, actually I got it by a slightly different route, but essentially I have a JKS file that is valid in the Techila environment in CSC. So I will now show you how you can configure the Techila SDK and connect it to the Techila environment in CSC. So here are the relevant files in this case. So we have the Techila SDK.zip, which is the Techila software development kit in compressed form. And I have already extracted it. And when you extract it, it creates a folder structure with several different folders, such as this Techila, which is the root directory. And then we have some other relevant folders as well. So I have already downloaded and extracted it. There is no installer per se. You don't need to install it as a program in Windows or Linux. It's a zip file, and then we will do some additional configuration so it works in the CSC environment. And then another relevant file here was this marco_csc.jks. So this file contains my personal user credentials for the Techila environment. And now I'm going to start the configuration. So I'm going to go to the Techila directory, and I'm going to create a copy of this file. So this Techila settings file. Copy and paste. And then I'm going to remove the template suffix. So the name is simply Techila_settings.ini. Then I'm going to edit the file with the text editor. And there are a couple of lines you need to change. The first line is this line, which defines the network address of the Techila server. And the second line is this key store line, which defines the location of the JKS file on your computer. So let's start by configuring the hostname, which is Techila srv.csc.fi. And then we are going to configure the location of the key store file. And on this computer, it is located on my desktop in a demo directory I created for this webinar. So I'm going to copy the directory from here, paste it here, and add marco_csc.jks. So that defines the location of the key store file. And that would work, but there's also another way to do this. So when we are editing this file, we also have access to macros, which are these values in curly braces. And I'm going to show you how you can use this initdir macro to configure the location. So this is just my personal preference. I think it's easy to keep the JKS file in the same directory as the Techila SDK is. So I'm going to copy this file, and then I'm going to go to the Techila directory and paste it here. So it's in the same directory with this Techila settings init file. And when they are located in the same directory, I can use a macro to point to the correct location. There. So that's configuring the Techila settings init file. So we just need to configure the network address and the location of the key store file. And then we need to do some configuration in R. So we need to install a couple of dependent packages, and then we need to install the Techila package itself. So I'm just going to clear the environment a bit so we get a nicer view. Okay, so the first package that we're going to install is R-utils. And you don't need to remember all of these packages or what the names are. They are documented in the Techila with R document that's included in the Techila SDK. So no need to try to remember or try to read it from this video. You can also check the documentation. So that's the first package installed, and then we need to install another package called rjava. So those are the third-party packages that are needed. Then we need to install the Techila package, which is included in the Techila SDK. And the way you install the Techila package is first you need to set your current working directory to a directory under the Techila SDK. So I'm just going to go to my demo directory. So we are going to go to the root directory, then to the lib directory, and then to the R directory. And select. And then we are going to install it. And the install command is quite lengthy, so I'm just going to copy paste it from here. And you can do the same, you can copy paste it from the document, but essentially we are installing it from the source files and we are not using any repositories, and we only want to install it for the R version we are currently using. I'm just going to copy that and paste it here. Scroll up a bit so you can see better. Okay. That's a command. Just execute it. Okay. So that was the installation done. And now I can execute library Techila to load the package. So now I have configured the Techila settings init file, so it points to the Techila server in the CSC environment, and I also configured the location of my key store file. Then I installed the required packages for R, which for RUtils, RJava, and the Techila package. And now I'm ready to try the installation and to verify everything works. And the way you can verify everything works is to run one of the examples in the Techila SDK. So I'm just going to close this one. And I'm going to navigate to the examples directory in the Techila SDK. So Techila root directory, examples directory, R, and let's go cloud core, and number of jobs, and select folder. So now we are in the correct folder, and I'm going to just open the run_jobs. So whenever you see a source code file that starts with run_, it means that it is the Techila version of the code. If you see a code that starts with local underscore, it means that it is a locally executable reference function which can use to compare the differences in the local version and the Techila version of the code. So I'm going to open the Techila version of the code. And in this case, actually, I ran this earlier, so there is my modification. But this is the example as you would expect to see it when you open it yourself. So it starts by loading the Techila library and then defining a function where we use the cloud core to execute a very simple arithmetic operation. So we are again multiplying the value I with itself. And as we are using the Techila environment in CSC, we need to modify this example so it has the R version parameter and set the value to env. Now we can save the file and source it, and then I can run the code. So now I have this run_jobs function, which is this function you see here. And it needs one input argument, which is the value loops. And the value loops will be used to define the range for value I. So it will calculate iterations from 1 to the value of loops. And if I give the input argument 10, it will iterate over values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it will do it in 5 jobs. So it will not create 10 jobs, it will create 5 jobs in this case. And the reason for this is that we are using one control parameter for cloud core, which is used to define how many iterations we do in each job. So now we have this value 2 here, which means that we will do 2 iterations per job. And because we are doing 10 iterations in total, we will have a grand total of 5 jobs in the project when I run this. And now, because I'm using the Techila environment in CSC and not my demo environment, it is prompting for my key store password. So as I mentioned earlier, the JKS file is password protected, and when you receive your JKS file from the help desk, you will also receive your personal password. And as mentioned, this is your personal user credential, so it's not a good idea to share this with anyone, because if you give them the JKS and the password, they will have similar access to the environment as your account. So this is personal. So now I'm going to write in my password. Hit OK, and I probably did some configuration mistake. Let's see. So we get to do some debugging as I had a demo effect. So let's check it out. So it said error in init, and the actual error is init file key store file not found. So this error means that it read the configuration file Techila_settings init, but it didn't find the key store file. And I immediately see that I made a mistake when I entered the location. So this inidir is replaced automatically with the location of this, this file. But I forgot to remove this Tequila directory definition here, which means that it tries to find it from C users, Markov desktop, CSC webinar, Tequila SDK, Tequila, and then Tequila Sdk. So it's trying to locate it from a different directory than it actually is. So I remove it, I hit save, I run the code again. And now it again prompts for my password. And now it's connected to the environment, but it was quite quick, so I didn't get a chance to drag the status window to the correct window. But anyway, I just try to run it again. Let's see if I can. Now it's quite quick. But these are now executed in the Tequila environment running in CSC. So despite the one mistake I did, it was quite easy to configure. You just need to define the location of the key store file in the ini file and tell the network address of the Tequila server. And after that, you need to install the required packages, and then you can modify one of the examples so that you add this R version parameter there, and then you can test it. And this is a very trivial test. It's not in any means a good case example. It's just basically a smoke test to test that the system works. And in this case, we are multiplying the value of I times I. Actually, I'll just store it in some result to show you what it looks like. So I'm going to execute run_jobs, so this function, and store it in variable res. Now it's taking a bit longer. And now we can access the value of res to see that it has 10 elements. So values from 1 to 100, which correspond to the values if we would execute the 10 loops locally, where we multiply the value of the for loop counter. And now just to do a smaller modification, let's modify the code a bit so it divides the value by 100. I will save it, and then I will source the new file, so it executes the new code. And let's store it in res2 run jobs loops. And now we would expect to get 10 elements as results, but the value should be divided by 100. And as we are waiting for this, I'll just go through the other parameters as well. So each of these examples has this .sdk root parameter as well. And this defines the location of the Tequila directory. And here in the examples, we are using this dot notation to refer to the path, but you can also define the path directly there without using these dots. This just depends. The reason why we have this notation in the example material is that when we use this notation, you can extract your Tequila SDK anywhere, but because the folder structure is known, it will still work. But if you, for example, extract your Tequila SDK to the root of C drive, and your path to the Tequila directory is C Tequila, then you could just write the following value here. And it would work just as well. And now we got the results. And let's just check the values. And the values range from 0.01 to 1, meaning that it executed the new code that we ran in the Techila environment. But as you see, it took quite a long time, and it was trivial computation. In CSC's title cluster, Techila is running on the same nodes as the Slurm scheduler, and sometimes if there is a Slurm load on the nodes, the Techila jobs might take longer than expected to complete. And in this case, I think that was probably the cause, because the code is very trivial and doesn't require any computational time. But instead, I think we just needed to make room for Slurm jobs that were processed on the same node. And then I think I'll just quickly show you the Techila SDK a bit more. So when you extract the Techila chip, so when you download it from the CSC website, you will get this Techila SDK chip. And when you extract it, you will get the folder structure you see here. So you will get the Techila SDK root directory, which will contain these directories. And the doc directory contains lots of useful documentation, including a document named Techila with R, which contains walkthroughs of all of the example material that is included in the Techila SDK. And it also contains the configuration instructions you can use to install the required packages on your computer. And then, in addition to that documentation folder, we have this examples directory, which has examples for several different programming languages. But in this case, we can check out this R directory, which contains all of our R example material. And the Cloud4 folder contains example material that uses the Cloud4 helper function to push computational workload to the Techila environment. And then we have other folders, such as the tutorial and features folder, that use the teach helper function to push computational workload to the Techila environment. And the tutorial examples are very trivial. They are essentially similar computations as the one you see here, which is done with Cloud4. They are just smoke tests that you can use to test that the system works. And then we have simple examples that show how you can pass input arguments for the executable function, what syntax you need to use to transfer additional data files to the workers, and all that kind of useful stuff. So let's just give you a quick glimpse of this R. So let's go to the tutorial to check out the teach example material, and then let's look at how we can pass additional data files to the workers. And in this case, we have a couple of different R scripts. So we have run_data files. And as I mentioned, whenever you see a file which starts with run_, it means that that file contains the Techila enabled version of the code. And whenever you see a local underscore function, that's the locally executable version. So let's just look at what this looks like. So this is the local version. It just reads the file, data file.txt, and then perform some simple operations for that file. And then we can check out the Techila version of this file, which is using teach. And there are a lot of comments, but the number of code lines is actually quite small. So we load the Techila library. Then for this example, the most important bit is this data files parameter, which is used to transfer this file from this directory to the Techila environment, where it will be copied to the same temporary working directory with all of the other files that are used in your computational project. But I think it would be a too ambitious task to go through the Techila examples all together. So we can, I think I'll stop with the examples for now. But if you have any questions, just feel free to write them down, and we can revisit this example or demo stuff later if need be. And next I'm just going to wrap up my 2 slides that I would like to go through. So that was the Techila configuration in CSC. So I showed you how you can configure your Tequila SDK to connect to the CSC Tequila environment and how you can request credentials that are needed to access it. And this was a very short webinar, and there is lots and lots of information I didn't get a chance to share with you, but I just listed some of the most relevant useful links here that you can use to get more information about the Tequila system. So the first one is our website, which contains all of our information, and then we have a technology docs page there, which contains our documentation. So the same documentation is included in the Tequila SDK, but you can just visit that link and you can download it from there as well. And we also have a forum available on our website, and if you have any questions, you can just also register there and ask away. And we also have a YouTube channel that contains some useful videos that show you how you can use the Tequila system and configure it on your computer. And if you get started with using Tequila and CSC and run into problems, and now feel free to correct me if I'm wrong, Seija, the first point of contact would be the help desk at csc.fi. So send an email there.
Indeed, and I would like to point out that please don't hesitate at all. It's our main contact to our customers. So even if you feel that it's a small question or stupid question, it probably isn't. At least it isn't a stupid question. We are happy to answer those. Thank you, Marco. Now is time for questions if you still have them. I'm also, while you are getting ready to type there, I'm also adding to the chat window link to our not Techila but R itself documentation. There are also other ways to do parallel computation, and I have done my best to give a brief introduction on several other ways of how to do that using CSC environment. Personally, I really like this Techila approach. It's in a way user-friendly, but for some really heavy stuff and let's say more complicated things, there are other ways too. It's basically up to you to choose and think which way works for you best. A lot of the things that Marco mentioned in the first half of his talk also actually are valid to other ways of doing parallel computation. Any other points? The record of this webinar will show up on YouTube, on CSC's YouTube channel at some point. So if there's something you want to check again, that will be available. Otherwise...
And Mario typed it in the chat window, but I'd just like to say it out loud as well. So there will be a Techno with R training session where we will give a lot more information, and you will also get the chance to try it out yourself on your own computer. And it's scheduled for the 31st of this month.
And I see that one of the participants has already signed up. So you're all welcome there, but please do sign up, otherwise we don't know how many cups of coffee to bring you.
Yes.
Speaking of coffee, if there are no questions, then I suppose we are all free to go to our respective places to have a break.
Yes. Thank you for taking the time to join. And as Seija mentioned, if you have any questions, just feel free to ask. Yep.
Thank you, and see you again maybe in the next edition of CSC's webinar, whenever that will be and whatever subject it will cover.
Yeah. Thank you.
Thank you, and bye everyone.